Alright, hi again class. This is your second practicum video. Our topic for today is downloading and digitizing data in QGIS. I'm again using version 2.18, which is the current long-term supported version. So basically I've got the screen where we left off. You downloaded the zip file from Blackboard and you loaded the QGIS project file, and you're basically looking at something like this, right? You have this Landsat pen sharpened image that I have made for you as a nice background. Oh geez. Alright, sorry about that interruption. Actually, that was something dealing with the lab to install the blinds, so that's all happening for you guys. Hopefully by the time you're in the lab on Thursday, there will be blinds and a new lock. So, back to what I was talking about earlier. Basically what we're looking at here is the Landsat image that we had before with the survey points on it here. Now, I showed you last time how to style some raster maps, and I showed you particularly a digital elevation file, which is simply a raster map where the data that's encoded into the little grid cells is the elevation of the Earth at that particular point on the landscape. I got a little bit ahead of the game there because what I want you to do in this practicum first is to actually find out where to get and how to download and bring in that kind of raster digital elevation model. That particular data set that we're going to be using is called the SRTM. That stands for Shuttle Radar Topography Mission. It was basically a mission run by NASA while we still had space shuttles, where they actually attached basically a radar arm to the space shuttle, which then flew around the globe, shooting radar beams down and then calculating the topography based on that active sensor. So the good thing about SRTM is that the active sensor produces very accurate topography, much better than other methods of estimating topography. So radar topography is very accurate. And relatively speaking, for the whole Earth, it's high resolution because it is now available around the entire world at 30-meter resolution. So each little grid square is 30 meters on a side. Okay? So that is probably, to my knowledge at the moment, the highest resolution, highest accuracy digital elevation data that's available worldwide. Now there's higher resolution and probably higher accuracy digital elevation models available for particular parts of the world, including LiDAR data sets, but like I said in class today, you pretty much have to pay for most of those kinds of things or create them yourself. So let's talk about how you get, in fact, a lot of data, including this Landsat imagery that I already downloaded for you behind here. It all comes from one data clearinghouse that is maintained by the USGS, the US Geologic Survey. So I'm switching over here to my web browser, and you can see the URL here, earthexplorer.usgs.gov. Right? This is your not total one-stop, but this is a pretty good one-stop shop for lots and lots and lots of free digital GIS data. Now the first thing that you'll have to do, I'm going to move my little screenshot guide down a little bit, is you're going to have to make an account. And you have to go to register over here, and it will ask you some stuff, username, password, all this stuff, and it'll ask you some stuff about the context in which you're going to use the data. Just say educational license, it'll ask some other information about that. But basically you're using this as part of your education and part of your scholarly work, so that's what you put into this. I think they just want to know for statistical purposes so that they can justify the budget they ask from the government, what their products are being used for. So please fill out that information for them because we want the government to fund this for us. We want the government to keep this open. So I've already made an account, obviously, many years ago. So I'm just going to sign into my account. It's very important that you sign in first because you won't be able to download anything until you've made an account and signed in. And the first interface you see, I'm just going to stick this, I'm going to stick me down in the corner over there, so just follow me over there, is this basic interface that looks a lot like Google Earth because, well, it's basically the same idea as Google Earth. In fact, look at that. It's Google Earth, okay? And you can pan on this by just clicking the mouse and dragging. You see the little hand forms like this. You can zoom in with your scroll wheel on your mouse, or you can use these tools over here. And basically you can change the view. You can have your map view if you really wanted to. I mean, obviously it's a little bit nicer to have the satellite view for looking at particular features. So what I want you guys to do is just to pan around on this thing like as you normally do and find Kazakhstan. Alright, there we are. Kazakhstan and Central Eurasia. And particularly what we're going to do is to look at this bottom southeast corner over here. So if I go back to QGIS, we're trying to find this same general area that has all of our little project survey little grids available. So we just want to keep zooming in to southeast Kazakhstan. Now this is Lake Balkhash over here. What really we wanted to see is where this area between Kapshigai Reservoir and the Tian Shan Mountains, which are down here. And your clue is Almaty, which is the second city. It's the older of the two potential, well, it's not really the capital. The capital is in the north. Where is it? Somewhere up here in the north. But it is probably the most populated city anyway, Almaty. So we're going to zoom down in here, and we're going to find Kapshigai Reservoir right here. We're going to put Almaty on the left over here, and then basically we're going to get a view that looks just like that. Look at that. I did pretty good. Zoomed into right about the same level. And so really what we want to do is to get some digital elevation models that match this same footprint. So we can potentially use DEM underneath the survey grids instead of the imagery. You know, when you're making your a thematic map, which we will do next time. So how do I do this? Well, I got to put some points. The cool thing is if you click and drag, you're panning. If you click once, it puts a pin. And you click again, it makes a connection, a line between them. And you click over here, and all of a sudden you're making a polygon. And the easiest polygon to make for this area is this sort of just rectangle. It doesn't have to be super accurate. You can zoom out a little bit more, and you can pull these things around after the fact if you want to make them a little wider or move them to a particular place. And it doesn't particularly matter because what it's going to do is show you what overlaps with this, not necessarily things that are only inside of this. So you just need to be able to touch the whole area reasonably well. Once you've done this, in fact, really what you've done right now is your first little bit of digitization, right? You digitize this search boundary box. What you need to do is, I'm going to move myself back to the corner over here, is to go to the left-hand side. And really what you see over here, these are actually your pins. You can delete them from here if you would like. You could also potentially upload a KML or a shapefile if you haven't already defined area. So that's pretty cool. And you can also add coordinates from here manually if you wanted to type them in. So you had GPS or something like that. You can optionally select the date range, so you only want the latest imagery or something like that. You could put that here. Personally, we don't care because there's only one current SRTM that we're going to deal with. And really all we do right now is after we've got the boundaries defined in this first set of tabs, or really just clicking on the map, we click where it says data sets down here. And right now is where we get to choose which one of these data that we want to download. Now in this section is some data that you may have to pay for, so not all of it is free. Typically here at USGS it's a nominal processing charge, meaning they charge you the cost that it costs them to process whatever data if it's currently unprocessed. So for example, I download for this region declassified spy satellite imagery from the 60s and the 70s called Corona satellite images. And they flew these missions covering obviously all of the USSR, and particularly Kazakhstan because that's where the space program was and some of their nuclear development was going on down here. In fact, the little town that we stay in, Alataw, which is around here, has a high energy physics laboratory from the Soviet period right in the middle of it. So lots of spy imagery. They're available, Freedom of Information Act made them available. The problem is that they're on physical film drums, and USGS has to scan them at very high resolution, turn them into digital files, and then make them available, and that costs some money. They got to pay somebody to do that. So I pay a nominal fee for them to scan one of those films that they haven't scanned yet. I think it was $90 a film, but the film covers like the whole area, so pretty decent price rate. It's not crazy. Some of the products cost some a little bit more, some a little bit less. Cool thing is usually once they've scanned it once, it becomes freely available to all. So all the tiles that I've paid for, you can download them directly here. I don't think you have to pay any more for them. SRTM, Landsat, some of the other big satellite missions are all paid for already. You don't have to pay a thing for them. And that includes our SRTM tiles. Now, you can spend some time looking through all of these things, and there's lots of information about them when you get into them. But particularly at this point, what we want to do is go where it says Digital Elevation and click on the little plus sign. And you'll actually see there's a whole bunch of other ones, including Aster Global DEMs, which are also high resolution, GTOPO 30, which is less resolution, GM-TED, IFSAR for Alaska, which is like basically like LiDAR, like infrared, and LiDAR. Now these are very limited data sets for just certain parts of the U.S. For global, basically Aster and then this other little plus sign down here, SRTM, are your two best ones. Aster is made through stereo imagery. SRTM, like I said, was made through radar, so it's a little bit better. And there's a bunch of other ones you can get, but the one that we want is the 1 arcsecond global. Now, an arcsecond is a unit of measurement that derives from a latitude and a longitude geographic CRS, coordinate reference system, one that is unprojected. So it's in a degrees-based measurement. That's what an arcsecond is. Roughly translated at the Earth's surface, an arcsecond is about 30 meters on the side. So that's why I'm saying the 30-meter resolution SRTM, although technically, since it's a global data set, it comes in latitude and longitude, unprojected coordinate reference system, and it will come in WGS 1984, ellipsoid, and datum. So once we've done this, we're basically ready to see our search results, and we click down here where it says results. Bang. And now we basically have 3 that it's found that overlap with our boundary box. And you've got a couple of tools over here, including the little footprint tool, which is neat. The footprint shows you exactly which parts of the Earth's surface our tiles cover. Now SRTMs are really nicely processed, so they match up exactly well side by side by side, and they go in order, and they have a name, SRTM 1N43E, so 1 north, 43 east, 076V3. V3 is the version of the SRTM data product. This is the most processed version possible. Shows you the publication date and resolution and even the coordinates for the bottom corner over there. You might want some other information. You can show an actual overlay of the information. So if I turn off the footprints and click the second one, now I can actually see a sort of low resolution image of what data I'm actually going to get. So that's pretty cool. You can already see the digital elevation information. And then I can compare a few things, but importantly I can also look at the metadata over here. And in that case I'm seeing the name of the actual SRTM tile, the date it was actually recorded by the shuttle, the date it was published, the resolution, boundaries, and a few other interesting things. Okay, so it's a lot of really cool information. When it comes down to it, what you want to do is to look at there's 2 ways to download it. You could add to a bulk download, which you don't want to do at this particular moment. This is for more special ordering. Instead, you want to click this one where it says download options. You can see you can download it in 3 different formats: BIL, DTED, and GeoTIFF. These are all just regular raster data formats. BIL is obviously the most compressed at 7.7 megabytes. DTED and GeoTIFF are about the same. I am telling you right now, GeoTIFF is still the standard, so let's download GeoTIFF, right? And what you want to do is navigate to wherever it is that we are going to save our data. In this case, remember, I made up my working directory, Talgar GIS data. I have my raster data file, and I'm going to put this right in there. And then it goes down like that. And then I can go to my second one, and I can do the same thing. Hopefully it remembers the directory, so it does for me. And then I can close that. And then I can do the final one over here, like so. And save that one right there. And that's it. And now we're basically done with Earth Explorer. You can close this out or leave it open and keep exploring whatever you want. We can go back over to QGIS and we can load those guys in. So remember I showed you last time we now have Project Home we can go to. This is just the easiest way to find where things are because we used our data organization format, our digital asset management, and we know it's right here in Project Home Raster, and then we have the 3. Now, if you hold down the Control key, you can select all 3 of them. You can right-click and hit Add Selected Layers, and it'll add all 3 of them at a time. And you note that it put them right on top. So again, the order of the layers over here make a difference. If we want to, we can put them underneath. We can now change the transparency of our pan sharpened imagery over here. I'm just going to do global transparency, something like that, and we can actually see the topography coming through underneath, and now it kind of pops out a little bit in 3D. And we'll deal with that, doing that kind of stuff in the next one. But basically what I wanted to show you now is how to download and bring in this kind of raster imagery. What we're going to deal with next, the second topic of today's practicum, is digitizing data. And to digitize data, like I mentioned in class today, we're going to digitize in vector format, but we're going to digitize on top of raster imagery. Now, this P-sharp, this LS8 pan sharpened imagery, is not terrible. It's 15-meter resolution, but you'll notice I can zoom in here to this particular scale, which I'll show you down here, 1 to 104,027, and everything looks pretty good. I could probably digitize on top of this. If I zoom in more, and again I'm using my scroll wheel to zoom in, see my scale is now 1 to 26, and I'm starting to see some fuzziness. Now, if I was interested in just digitizing these farm fields, this imagery would be fine. This scale would be fine. But if I want to zoom in further and to get something at the smaller level of the inside the farm field, well, I'm kind of out of luck, right? The resolution of this particular imagery is not compatible with the scale that I need to be at to digitize finer features within the size of a single farm field. You see how blurry it all looks, how pixelated it all looks. So what we need is a better resolution, a higher resolution imagery data set. And the cool thing we can do with QGIS is tap into available web-served high-resolution satellite imagery such as Google Earth or Bing Maps. And the way we need to do this is by using a plugin. So QGIS has a whole bunch of built-in things up here. You can explore these. We will explore this later in time. But the other really cool thing is that it has a lot of plugins that people have made to extend the capabilities. And you go up to the menu item and it says Plugins, Manage and Install Plugins. Right? You will have none of this stuff. Like I've installed these various plugins that I use from time to time. So you'll just have that one, Manage and Install Plugins. And you will see this sort of pop-up window, maybe a little smaller than mine right here. And basically what you need to do is in the search box over here, there's a whole bunch of them, so it's really hard to find just by scrolling. Just put in here, just put web, right? And then you'll get a smaller list of, let's see, of plugins. Did I put the right one in? Hold on a second, let me just remember. Let me just remember the name of the plugin. I'm telling you, I just drew a blank in my own brain. Yeah, Open Layers is the one that we want. Okay, sorry about that. Manage and install plugins, not web, but search for Open Layers. Okay, and you will find it. There'll be a few of them here, but you really want this one right here. And you'll see, actually, mine is saying I can upgrade this plugin. Yours will just say Install Plugin down here. Okay, so basically, it'll give you some information about the plugin, what it does, and some version history. So I'm going to push my upgrade plugin button. You'll push install plugin. So you highlight it over there and then click that. And then it downloads and does it. And now we're good. At this particular moment, this is the only plugin that you're going to need at this time, right? So install the Open Layers plugin and you should be okay. Now this may have been done for you already in the lab computers or something like this, but you know, give it a look through just to make sure you're understanding what's going on. Now, depending on what the plugin is, QGIS will put a menu item for it, kind of annoyingly, in different places. So many of them go right here under the plugins menu, which is cool. Some of them will add stuff into a hidden like area inside one of the menus. This one goes under web, okay? And you might not have this other one. You probably just have this thing that says Open Layers plugin. And now you have a variety of web-served imagery that you can overlay in your map project. OpenStreetMap is really cool data. It is like It sounds totally open, libre to use, but it's not satellite imagery. It is digitized maps from GPSs and that kind of stuff. Probably the one that you're most familiar with is Google Maps, Google Satellite, hybrid streets, that kind of stuff. It would work. We've had problems in the past with it because the registration of it is slightly off, right? Better to use Bing Maps, and specifically Bing Aerial. And if we do that, all of a sudden, it may give you that little yellow warning, but that's not a big deal. All of a sudden, now you see we have higher resolution imagery, the Bing Aerials. And you can go over to your layer manager, and you can essentially snap back and forth between them. And you can actually see the registration is pretty good between the Landsats and our Bing Aerial. Now, Bing Aerial has a certain limit that you can zoom into, right? That's about it. I think if I go one further, you get this like, oh, no imagery camera. So you got to back out just one little click on your mouse scroll wheel. So that's about as far in as we can zoom with Bing Aerial. You can see we can actually see individual trees. We can see funny anomalies in the middle of these farm fields. And really that's what you need to do, is to visually inspect this satellite imagery for anomalies that look funny. And by funny, what I mean is things that seem like potential archaeological features. Now, you don't have to randomly search across the whole map, because we have prepared for you, that's me and Sal, my student assistant, some survey areas that you need to look inside. Now, you're not just going to pick any one of these survey areas. You need to pick the one that has your name on it. How do you do that? Well, you go over here to the layer, the vector layer that says Survey Unit. You right-click on it, and you look for Open Attribute Table. Now, remember I said all vectors have an attribute table associated with it, even if it's just a blank, meaningless ID number. This table was made by Sal and myself, and you'll actually see a couple of columns of information. You have unit numbers over here, you have the location, these are just geographic names, and then you have your name, right? So if you look in here, you can actually find your name, and look at that, that's my survey square. And if I highlight it here, I can actually highlight the image, actually the particular survey square is highlighted on the imagery in the background over here. So you see the one in yellow? That's the one that I just highlighted. So let me resize this little table so you can see all of this stuff. Now if I highlight a different row, you'll see another one is highlighted. So here's Ramon's particular survey square. So basically what you need to do is to find your one right here. You'll see it's highlighted in yellow. And then there are a variety of things. You can click on this particular tool, which is a handy one, which is a zoom map to the selected rows. And all of a sudden, the map will zoom in to your survey area. Now that's really cool, isn't it? So now you know which one is yours, and this is the boundary area from which inside which you are going to survey for those funny anomalies that I'm going to talk about here in just a second. Before we do this, we need to do a couple of things. You want to get rid of the highlight in yellow. So up here, see this thing where basically you have this yellow box and this red no sign. It says deselect features from all layers. You do that. Now we got rid of that selection, just gets rid of the highlighting. What we need to do now is to restyle our survey units so that they are not opaque like this. And you could do this with transparency, but probably the easiest way is to just open up the properties dialog and then go to fill, simple fill, click where it says fill, and then make it totally transparent. All right, click OK. And then before we leave here, the outline, which is now black, I am going to change to white. I'll click OK. And I'm actually going to increase the thickness. And the reason why I'm doing this is just give me some boundaries that are bright so I know where to stop when I'm doing my survey, because we don't want you to survey outside of these boundaries. These are defined by landform, and we basically are trying to do some controlled statistics, so please, when you do your survey, survey within them. Before you start digitizing features, you want to do a quick sweep. Zoom in pretty far, until you start feeling comfortable with seeing things like this, and then start by scrolling around, right? You want to make sure you have this little hand guy selected. So find an upper corner, for example, and just start scrolling around, looking for things that look funny. And it takes a little bit of it takes a minute or two, or a second or two, you know, for the Bing imagery to update, because you're pulling things down from the web. What we're really looking for are mounds, okay? And this is going to be a little bit tricky, right? You're going to have to use your intuition. So this is like a tree, this is like a mound. This is a mound, this is a tree that might be on a mound, right? This looks like the guy drove a tractor around in a circle. Maybe there's a mound in the middle of that. And remember, there's the finite limit to which you can zoom into, so there is a little bit of a brick wall in terms of how you're going to be able to digitize these things. But what you're trying to do is to wrap your mind around the kinds of features that we're looking for. So I'll try and show you a couple of them, really nice ones. So this is one, this is clearly one. So you can see, particularly if they plow around it, but it also looks circular and mounded. These are the Kurgan burial mounds. There's a little one right here, and there's another one right here. Now the tricky thing is not all circular features, like this bare patch over here, not a Kurgan mound. It's just a grass feature. These little splotches are features of vegetation. Right? You have to use your intuition, but also you're going to be wrong sometimes, and that's okay. We don't mind false positives. Just don't digitize willy-nilly. You know, use your archaeological eye to try and differentiate mounds that look really round from just swales and bumps in the topography. And there may not be a ton of them in your area, but there is going to be some. We've double checked, right? So here's one that's not perfectly round anymore because it's been altered by human action, but that is one too. All right? And so basically where we're at this particular point is you've got your imagery, you've got your area that you're surveying in, and you've gotten familiar with the kinds of features that you're looking for. And now what you need to do is to create a blank vector shapefile in which you're going to record your observations and put a couple of overlays to help you do some measurements. Okay? So if I go back to Project 1 description over here, very importantly, it's going to tell me some codes that I need to use in my vector file for encoding the information. This is just to make your life a little bit easier, but also so that we do things standardized. All the files should be about the same. So what we're going to do is we're going to make a blank vector shapefile. It's going to be a points file, and we're going to make 2 columns in the points file that we're going to add our own data to. We're going to digitize the location, spatial information, and then we're going to encode some other information that we assess from the backdrop imagery. Okay? So just read through this again just to get your mind wrapped around this, and I'll go through this here in just a second. In order to create a blank new layer, you go up to the layer dialog, you go to where it says create layer, and you go to new shapefile layer. New shapefile layer. And at this point you can choose point, line, or polygon. We are going to do points, so we're going to leave that here. Selected CRS is EPSG 4329WGS86. Leave that alone for now. We're going to trust QGIS for the moment. But this is something where you have to be aware of the CRS systems just to make sure everything is copacetic. Because we started our project with the pan-chromatic Landsat, that's the project CRS, even though the Bing aerial comes in something different. It's doing its best to register that. That might present a problem down the line, but for now we're not going to deal with that. Okay? And here's where we have to make our 2 new fields, it says here, but these are columns. The first one is going to be called K_type. And we only need it to be 1 character long, and it needs to be a text character because you're going to put these single letter codes in there that stand in for this more detailed explanation. So what we'll do is we'll just type K underscore, not minus sign, not dash, type. And this is where you have to be sure not to have any spaces or anything like that. We'll throw an error. Alright? Text data is fine. We're just going to change the length to 1. No sense using more using deeper pixels when we don't need that deep of a pixel. Okay. Click to add to fields list right there. We see that by default you have an ID integer, K type, and then the next one is K size. K size. So K underscore size. Be sure to do all lowercase. We want everybody's tables to look the same. Click the field where it says text data, and here we're going to put decimal number. Okay, and the length we're going to put. Well, we're not going to have anything that long. We'll just put 20. And precision, we'll just put two decimal places, because you're not going to get anything better than that. And you hit basically add to fields list, and so now we have this. ID, integer, K type string, K size real. Okay? At this point, we click OK. And it's going to ask us to actually save our file itself. So what we have to do is to navigate to our data directory, right? QGIS data vector. And at this point, we want to create a new folder. Okay? And we're going to give the folder basically the same name as the shapefile. And for me, what I'm going to do is prof ULA Kurgans, right? Something descriptive, so I know what it is, right? I'm going to click enter, and then I'm going to put up here prof ULA Kurgan. Now we're going to create the actual shapefile itself. I hit the save button, and there we go. Now it by default adds it to our layer tree, but there's nothing in it right now, so you're not going to see any dots show up. Just to confirm, over here in my file browser that everything is in place, we'll go to Documents, Working Directory, QGIS, Vector. We see Prof ULA Kurgans folder, and inside that we see all of these things, including the actual .shp. Okay? So now we are ready to actually digitize our first Kurgan. All right? So here's our first one right here. Before we actually put our dots, it's actually useful to set up a couple of things to help us. I like to go up to where it says View, Decorations, and add a scale bar. Okay? And just click where it says Enable Scale Bar. And I like to put it in the bottom left. You can move it over from the left a little bit, like by 100 map units. Just hit Apply, and it puts it right here. Okay? And here you can change the size of it. So let's say we want to put 10 meters. We can hit Apply, and it would actually, oh well, because I didn't want to do that. Too small for it. Let's see what happens if we change that. Go up to 20. There we go. 20 is the smallest it wants to do at this particular scale. So we could do that, or we can make it bigger. We can make it 100, something like that. It's very useful to set it at a scale like that. So we click OK. One method of estimating the size, for example, of the Kurgan would be to stick it down next to that scale bar, and then you can use your fingers on the screen to basically do the thing I did in class today. It's about 15 meters, right? If I want to edit that, I would just go back to View, Decorations, Scale Bar, and say I want to change this back to 20. There we go. So now I could position my little Kurgan there and say, well, it's bigger than 20. It's probably about 25 or something in diameter. That's cool. That gets you a rough approximation, and you can do that if you want to do it that way. Write down in your lab notebook, this is what I did. Okay? Probably a better way is to set up a grid. And we would go to the same thing, View, Decorations, Grid. And then you click Enable Grid. And you can do the same deal. You can set the interval. So if I do this right now, it's a 200 by 200 meter grid. You see it black right there. If I want to do it maybe 10 by 10, it might be a little bit overkill, but I could try that. Now I have a 10 by 10 grid laid over everything. Oh, look, that's pretty cool. Now I can really start to estimate the size of this feature. But the weird thing about this grid is that it makes it a little hard for me to see the actually underlying imagery. So, what can I do about that? Well, one thing I can do is to change it to a plus sign marker, like that. Well, that's actually kind of worse at this particular scale. So maybe if I go to the line symbol, simple line, and let's see if I can edit that. Oh, it's not letting me edit that. Well, I can't really edit that either. So let's see what I can do. Maybe if I zoom in just one little bit, it won't look so crazy. Oh, I can't zoom in anymore. There we go. Well, basically what you'd have to do with this probably is, and kind of annoyingly, you have to go to Decorations, Grid, and then keep this off to the side, and enable and unenable it, and just hit apply whenever you need to do that. Now the grid's pretty cool because it actually lets you estimate the size of this kurgan, or maybe that kurgan over there. Which one was it? This one right here, right? So we can actually count over. So there are 1, 2, 3.5, so that's 35, right? 35 meters in diameter. So you choose which way you want. You can use the map scale, you can use the grid, but you need to be able to estimate the size in some way. So let's deal with this particular kurgan right here. Now that we have our blank vector file and we have our grid and all that kind of stuff set up, we can actually put this particular blank vector file into edit mode, and we can add our point. So what we will do is to click on this little pen that says toggle editing. And now you've seen a couple other tools have come into play. The one that we really want at this moment is add feature. So you click on this, and now you get a little crosshairs. And what you want to do is to find the center of the feature. In this particular case, we're looking at kurgan mounts. Find the closest point to the center of the kurgan mount. Click your mouse once, all right? You will get this field that pops up, and here we have basically all of our three fields: the ID number, the kurgan type, and the kurgan size. So ID number, you can just put 1 and keep a running tally. ID number is not critical, so if you get confused and you have 2 of the same ID numbers, it's not the end of the world. All right? Kurgan type, let's go back to our little code over here, and we'll just read through our options. We have mounted earth kurgan, rock covered kurgan, ringed kurgan, destroyed kurgan, or possible kurgan. So probably for this one, you know, to my eyes, this is a pretty intact mounted earth kurgan. I can't really see any of the other features, so I am going to use my code M, lowercase m. Kurgan size we just estimated at about 35. This is the diameter that we're trying to put in here, so 35. Click OK, and now we have a dot. Okay. Now what we can do is to go back to our hand tool, scroll to our next potential kurgan, which is this guy right here, and then get our digitize feature again, put our second dot, and now you see it actually kept our values in there because I have enabled a particular time-saving thing, which I'll show you here in a little bit, that populates it with your previous values. So I'm going to put 2, it's still an M, and the size of this particular one is probably 30, I would say, on rough approximation, and click OK. And now I can continue, and I can say, well, I don't know if this is a kurgan right here, but it's number 3. It's maybe a mounted earth one, but I can't really tell, so what's the code for that? Oh, P, possible kurgan. I will put P right here. And when I look at the size of it, it's much smaller, I would say roughly 15 meters. Okay? And now you can see I can keep going pretty smoothly by going back and forth between the panner and our digitizing tool. When I'm done, or when I want to stop for the moment, I go back up here, right? And first I click Save Layer Edits. If you don't click that, then the shapefile will not update, all right? And then I toggle editing off. And now I have just the regular view. I can always go back and re-edit this. I can move these points around. I can edit the table. I can add new points to it later on. But you want to make sure periodically you're saving this one where it says Save Layer Edits. These ones up here save the project, which again doesn't have any GIS data, just the layers in it. So you may want to save the project to the same project file so you can get back right to what you were looking at before. But you want to make sure you also save the edits, otherwise you will lose them. So save both of them. They're saving in 2 different places, 2 different things. The layer edits save to the shapefile, the edits that you did. The project save saves just what styling and layering and what zoom you are at right now, so that you can come back and start right where you left off. Okay? One last thing that you can do is to go to the project properties, and you can check out your CRS over here. This is your coordinate reference system, and get some extra information about that. And make sure that things are cool there. You can check out some other information you can add to your project, like title. You can change the selection colors and all of this kind of stuff over here. So you can fool around with that to make everything styled and work the way you want it to. The other thing that you can do is go to, let's see, view. Sometimes I lose track of where things are. Is it under edit? No, view. Layer. Let me pause for just 1 second. I'll be right back. This is just one little tip that is like a set it and forget it kind of tip, so I just got to refresh my memory. 1 second. Okay, figured it out. Quite obviously, it's under the settings menu. So you click under settings, you go to where it says options, and here you can actually customize some of the same stuff that you can do in project properties, like the selection color, etc. But importantly, what you can do is go into this Digitizing tab right here, and you can check this box that says reuse last entered attribute value. So remember when I was clicking my points over here, when I clicked into the second one, the fields were already automatically populated. That can be a big time saver. So if you check that box right there, it will just transfer whatever you entered last into those boxes. Particularly as you're going with the ID number 1, 2, 3, 4, 5, it shows you the last one you used. And if you're finding a lot of mounted earth kurgans, keep that M in there and just do all the mounted earth kurgans, and then you can go back and do all the rock kurgans, all the possible kurgans in a row. So you have to click less in that little dialog, and you have to type less in the little dialog. We've made our life pretty easy by using codes that are only 1 character long. But, you know, the easier you can make your life while doing this, you can probably tell, the happier you're going to be at the end of the project. So that does it for now. This is a little bit of a long tutorial because we covered a couple of things: importing, downloading data, and digitizing. At the end, what you can do, you'll have basically all of your kurgans digitized, and you'll have some really cool data about them that you can use to make the thematic map, which is what we are going to do next time. Alright, so I will see you on Thursday, and we can go over all this stuff some more in person. Later.